In this lesson, we're going to learn how the air masses move from one source region to another. And the leading edge of the air masses is called a front. It's a boundary between the air masses, whether it be hot, cold, dry, and moist. As they move, the leading edge will be the actual front. There are four types of fronts. You have cold fronts, leading edge of cold air, usually from the polar. Warm fronts, which are leading edges from tropical regions. Stationary fronts are fronts that are a battle zone and do not move between warm and cold or dry and moist. And occluded fronts are when similar air masses catch up to one another and they are then wrap around and have their own unique weather situations. All right, the cold fronts. Cold air is replacing warm air by uplifting the warm air over the cold air. Cold air is much more dense than warm air. And dense objects tend to sink compared to objects that are less dense. So warm air will rise on top of the cold air. It's a very steeply sloped front. As it comes in, it's very vertical and can produce severe weather, thunderstorms. Especially this time of year, we are still getting cool air left over from winter coming into our advancing warm air as the summer is approaching, and we usually get our biggest storms in the springtime. And they're usually fast moving. Cold air is so dense it really can get moving quickly into a warmer air because that high density accelerates it. The symbol is a blue line, if they're in color, with the pointy triangles on them. And the triangles are pointing in the direction of the advancing cold front. So in this picture, it's moving upwards. And as you can see from this little graphic here, the cold air is pushing to the right in a quick fashion, and it's a very steep front. It's almost vertical. And the warm air is lifting very quickly up into the atmosphere, up in the stratosphere, forming the clouds, and cumulonimbus clouds will form. Good chance of storms. Next one's a warm front. Warm air is replacing cold air by pushing it backwards. So the warm air, which is less dense, is coming in and usually at a slower rate. It's a gentle slope because the warm air is not as dense as it's pushing the cold air. It can't push as much. So it kind of rises up over the cold air and pushes forward at a very sharp angle. These kind of produce steady rain over a large area, so you may have a few days of rain, gray skies. It's preceded by cirrus clouds, then cirrostratus, then altostratus, then stratus, and finally nimbostratus. Again, the warm air is rushing into the cold, but it's pushed up above the cold, which is more dense, to the highest parts of the atmosphere. And it slowly, those layers of clouds will lower down to the point where precipitation forms. Again, they're slow moving because they're just less dense. So there's a symbol for a warm front. It's usually red if it's color, and you have the rounded half circle semicircles. And the side of the semicircles is the direction that it is moving, so this would be moving up. And on this graphic, the warm air is coming in from left to right. And you can see the very sloped appearance of the front. The very front edge is way out here on the far right, and you get some very high altostratus clouds. And over time, as this front's moving forward, the clouds will lower and lower and lower as it goes from left to right. It takes a while for that to happen. Eventually, they get low enough, thick enough that we have some precipitation. All right, next one's an occluded front. It occurs when a fast-moving cold front overtakes a slow-moving warm front. It has the same characteristics of a cold front. So if you notice, it has a mix. Well, the color is purple, red and blue mixed together make purple, and it shares the triangle and the circles alternating. And what happens if you follow this in sequence? You have a warm front up here and the cold front behind it. And over time, from 1 to 2, the cold front's catching up to it, to the point where here's the occluded front. So it's really it's two fronts in one. It's overtaken that, and it'll have its own weather situations. So So here's a side depiction of an occluded front. And it has an example. Here's Monday. The warm air that showed the warm front went through. So you have some warm air occurring. And there's cool air that was just before the warm air. Eventually, this fast-moving cold front zipping along, it comes into the point where it catches up to the cool air in front of the warm front, and the warm front air is pushed up higher. And again, you can get some gray, dismal days here, light precipitation. Once that eventually happens. And last one, stationary front. It's neither ass is moving. You have a cool and warm air masses. Moisture could be dry or moist, doesn't matter, but the hot and cold fronts are not moving. It has a warm front characteristics, so the clouds and gray skies. Notice how the blue triangles point in one direction, the red semicircles the other, and that front's not moving either direction. The name implies sitting still. And generally with this situation also you get a lot of rain, heavy rains, or training storms, storms that keep reforming over the same area. Now please go to the simulation for fronts in your classroom and play around with the cold and warm fronts and see how they affect the weather, and you have a small assignment with that. For this lesson, from the Google Classroom, hit weather fronts, and you'll get into this little simulation of weather fronts. Now there's only 4 types we talked about: cold front, warm front, occluded, and stationary front. And 3 of these can be a little bit interactive. So what you do, you hit whichever one you want to do first. Here's cold front. And what you can do is you can take the cold front on the left-hand side, you can drag it into the warm air. And you can see what happens as the cold air comes in. And hopefully you recognize that type of cloud formation. And then I go back to the menu button, and I can hit warm front. And the warm's on the left, I can drive the warm air into the cold air. And then looking at those clouds, hopefully you can determine those type of clouds also. And go through occluded. So I think stationary won't do anything because, well, the front's stationary. I think that one just moves on its own. So play around with it a little bit, and then there'll be a couple questions from Google Classroom for an answer on both the cold front and warm front. All right, folks, have fun.